Hello sir, we are students of QI Electrical from Sanjini College of Engineering. We are going to present the activity of implement Routh Hurwitz criteria for the given transfer function in MATLAB to verify result via time domain simulation of step response. And the topic is presented by Abhiraj Kalwagi, Prathamesh Lamkade, Tushar Mahajan, Aya Ravishkar and Karthik Maske. And this is guided by Dr. Vijay Kumar sir. In this activity, we are going to perform about introduction, objective, out harvest verification, step response analysis, simulation result, advantages, application, and at last we are going to conclude it with the proper conclusion. About the introduction, in this, stability means the output remains bounded for a boundary input. Important for proper functioning of control system. Routh Hurwitz method checks stability without solving roots. Because of this, to analyze the stability, it gets easy. Next, uses characteristics equation of the system, and also it is useful for higher order systems. It is mostly used in higher order systems, and it is very useful for that system.
Hello sir, hello everyone. My name is Abhiraj Kalwage. Today we are explaining the objective of Routh Hurwitz methods. Uh, First objective to analyzing stability of control system. The main the check whether system main controls check the control system stable or not. Second advantage is to implement system simulink. We build and run system simulink. We see how it works particularly. A third one is to observe time response and step response. We study step response, understand how output change within the time to verify theoretical result uh, particularly. We compare theoretical result with simulink result, verify accuracy. Last one is to understand system behavior visually. Overall, it helps to clearly understand system uh, behavior using a graph. Third slide is Routh Hurwitz verification. Uh, uh, we found one characteristic equation, and then we create one table, Routh Hurwitz table. After that, we check after we check sign change in first column. If the sign if the sign not change, system is stable, and last is compare with simulink result. Last slide, step response analysis. How what are the steps from Routh Hurwitz? These are shown in this slide. First step is uh, step response showing system output over a time. Stable system output settle at steady value. Unstable system output is increased continuously. Oscillation system output is frequently used used to verify system performance. It helps to use verify the system performance. Thank you.
Good afternoon, sir. My name is Pratham Islam Kade. My name is Pratham Islam Kade, and I am explaining the Routh Hurwitz criteria program. Here is first our column is CLC clear. It is used for a clearing window of MATLAB. Then we are using another tag is define denominator coefficient. Here we are using a polynomial equation. It is s raised to 3 s cube plus 2s square plus 3s plus 4. It is our polynomial equation for the Routh Hurwitz criteria. It is our example. Then we are using the transfer function. Here the create transfer function. Here we are using syntax TF. TF means the transfer function, and our 1 is the coefficient of S square S cube. Then we are going to our uh, third number of point. It is a Routh Hurwitz table. N is the length of our polynomial equation, and the Routh is equal to 0 n cillian. It is our formula. It is our formula n slash 2 means number of n divided by 2. Then we go to our first row. Here our first row is route 1, then 1.2 and route 2.1 length 2. Here we are doing cross multiplication between s cube and s square. Their coefficient cross multiplication we are doing here. Then we are going to compute the remaining rows. Here is computing the remaining rows. Here are the I is equal to 3. Here our coefficient are 3 n, and j is another variable. Size 1 route 2.1 route j is created. Route 2 is created. Here j is equal to 1, size route 2 minus 1. Route the number of coefficient I and j. Here the I and j multiplication of both term, and we are finding our another term. Then we are finding the another term. There is a route I minus 2 into minus 2 1, and route I coefficient minus 1 and j plus 1 here. And third one is route I minus 1 and 1 end. Then we are display our route array. Here we are doing that program. Here we are displaying route array, display route. Here then another step is we are going to checking our stability check. Then first column route 1, and the sign change, some different sign first call is equal to 0. If sign changes is equal to 0, if sign changes is equal to 0, display system is stable. Else display system is the our output is not 0, then display system is unstable. Here is the end. And then we are going to our step response. Here we are writing this code for step response. Here we can create one image of stability of Routh Hurwitz. Then step syntax, title of our figure is step response. Our grid is on. Then we are finding our result. Here is our step response result.
This is the output of our Routh Hurwitz criteria. The response shows the oscillation that gradually decreases with time. This means the system is stable because the output finally settles at a constant value 0.25. The oscillation is indicated the system interrupt. The initial peaks above the final value respond overshoot. Over time oscillation reduces. This is called as damp response. The system reduces the steady state after around 25 to 30 seconds. All the poles in the left half of the yes pole from Routh Hurwitz. The system is stable but undamped.
So the simulation result of our topic, the first point is graph plotting. The output response was capture using the simulating scope blocks. Output response: the system reaches its steady state value within the expected time frame, exhibiting the design transient characteristics. Performance matrices. There are two types: rise time and setting time. The rise time, the time taken for the response to rise from 10 to 90% for under damped systems was observed. Setting time, the time taken for the response to remain within 0.2% error band of the final value was recorded. The stability: the system response does not deliver conforming visual stability with no continuous oscillations. Validations: the simulated outcomes, waveform and key preference matrix closely match the calculated uh, theoreticals. The applications are applications of advantages, which are control design, determining the uh, range of gain which a system remains stable. System analysis, checking the stability of high order characteristics application without complex root finding calculations. Robustness check, analyzing how the parameter variations affect stability margins. Frequency analysis, identifying the frequency of certain oscillation for marginally stable systems using the oscillatory polymer methods.
Uh, Good evening, sir. Myself, Karthik Muske. I am explaining the application of Routh Hurwitz criteria. So first is control system design. It helps engineers quickly check whether a system will be stable or unstable before implementation. That's second is electrical and mechanical system. Electrical and mechanical system, it is used to analyze circuit, motor and dynamic system where stability is critical. Third is robotics and automation. In robotics and automation, stability ensures smooth and accurate movement of robots and automated machines. And fourth is signal processing system. In signal processing system, it helps maintain reliable signal behavior without oscillations or de-oscillations. And last one, fifth one is industrial system analysis. In industrial system analysis, it is used to evaluate performance and avoid system failure in real world applications. And next slide is, last slide is conclusion. Uh, Conclusion, the implementation of Routh Hurwitz criterion using tools in like MATLAB, Simulink, and stability analysis of control system. It provides a theoretical method to determine system stability without solving roots. The step response analysis verifies the result practically by showing system behavior or over time. And simulation tools helps in visual understanding of system performance. And this approach improves learning and analysis